I'm sure it's okay. All right. Sorry. Back to this. What was I saying? Oh, what two ions does this dissociate into?
H plus, I minus.
Good. H plus, I minus. AQ, AQ. That's an acid. Acids dissociate and they produce H pluses. That's why they're acids, right? And it conducts electricity because of that as well. Acids conduct because of the ions. I think I had your hand raised.
Yeah. A little, can you refresh my memory as to why, how do you know which one this one's going to be?
How do you know each one? This, the charge?
Yeah.
Oh, you can go to your periodic table and look in the top right corner of the box, and H has a +1, -1. It's always +1. And then I has -1 and then a bunch of others. You always take the top one, so -1. Down here, it dissociates into Mg +2, and here's the kicker here, 2 OH -1. 2 OH, because there's 2 OH here, you got to balance the mass. Conservation of mass, conservation of charge. This is +2, that's -1, so I need 2 of these to balance that out to a 0, because this is a compound with a charge of 0. So, I know you guys had some issues last week doing this, so I wrote it down. I wanted to practice again. Everything look okay?
Yeah,
Okay.
the breaker holds the valve open.
Okay.
It's fail closed,
Okay.
and the solenoid's getting hot, so that's why it's humming.
Oh.
So I shut the breaker off.
Okay. Yeah, I don't need gas.
That'll
Anyway.
cool it off, and then, yeah, when you need gas, we'll turn it, well, I'll come check it and turn it back.
You know what? I don't think I'm using gas again the rest of the year.
All right,
actually.
we'll leave it off, and then I'll check it over the summer.
Yeah, because the next lab, no, I don't think I'm going to be using it.
Yeah,
So,
because the whole time the breaker's on, it's holding the valve open.
okay.
And then
So does
when
that
you
need to be replaced or something? Or?
It could be.
Do you want me to put in a work order?
Yeah, if you think of it, yeah, it'd be great.
What the heck's it called?
It's the, it's the solenoid gas valve, it's a gas solenoid valve.
I don't know how to spell that.
S-O-L-I-N-O-I-D. Solenoid. Yeah.
That right there is how you spell it?
No E on there, but just the solenoid, yeah.
Solenoid valve.
Yeah.
No one here has seen
Making
Gas.
noise for the gas, right?
Okay. All right.
So now the gas is off,
Okay.
because the breaker's off, because that holds the valve open. It's kind of it's backwards to what you would think, but it's fail safe, which means fail off.
Okay.
So that's why.
All right. Thanks.
All right, thanks.
All right. Here we go. Back to this. So, yeah. Hopefully that makes a little more sense to you than it did last week. This is a base because it produces OH minus. Acid produces H plus. Remember that. All right. Isomer. What's an isomer? Different structure, but same formula, same number of atoms. So, can anyone tell me what to draw here? Go ahead.
Alright, so you're going to draw 3 C's in a row, alright? And then you're going to have, on the middle C, you're going to have another C going off that, I think. And then I put the double bond O, which I think you need, and then the OH at the end, yeah.
Good job. That's what I would do as well. That's 2-methyl-pro... Wait, what class of compound is this? Organic acid, right. This is, don't say it out loud. This is called 1, 2, 3, 4. So bute. Catherine, what would the name of this thing be? Close. Butanoic acid. Butanoic acid. This would be called 2-methyl-propanoic acid. So I wanted to review isomers with you. Don't forget you got your quiz Tuesday, and I'm actually going to hand out the answers to that review packet that I gave you. I'm going to do that right now. Yeah.
What's the condensed formula for that one?
This?
Yeah. Oh, so we actually have to draw it out?
Like that. You want it all condensed, like no bonds at all? This would have to be branched, but these, I would just erase those.
Okay.
So that's it. Alright, pass up journals, pass them all over to Dan.
Yeah, great.
Oh, I lost mine out here, Jess.
There goes someone's pencil.
It's,
Oh, you got it.
there you go.
Don't put that near the desk.
Oh.
I'll get it when I get up.
Okay.
There you go.
Grab the Scarlet.
Here, I'll take it. Where do you want these, Mr. McCoy?
Brad, you get those worksheets? Just right on top of Michelle's post-it.
Mints are getting passed out there.
What? What?
All right.
So we get mad mints.
Oh, Miss Chrysler.
Hey, you guys were really good the other day, and I said I would bring them with me. I'm
Yeah,
sorry.
you want one? Go grab one.
Hey, give me one.
Don't lose this. Answers to your review sheet.
Wait, this is
Answers to that review packet.
the actual review assignment.
The review packet for the outside.
Did you take two?
Yes.
All right, just take it and sit down. Let's go.
You can't just take
Just take one and sit down. All right. So what I just gave you was the answers to the review packet for your quiz next Tuesday. So you can look them up on your own. You don't need me. Okay? So it's not an assignment. All right. So that's that. You can put that away. Go to those worksheets now. Let's go over the one with pH and H+. Did we do that yesterday? Oh, we did?
Yeah. We finished that one.
This one with the.
All right. Did we finish going over this?
No, we were actually on number.
No, this one.
Yes.
that one, yes.
All right. Those of you who were not here yesterday, who are you? Just Ben? Brad? Everyone else was here yesterday? Okay. So we did this yesterday.
Yes.
We do not need to do it now.
No.
Okay. Let's go over this pH scale.
I think we were almost done that one.
You know, I'll just start over again really quick.
No, you only did 4.
I know we did 4.
We got to take notes on how to do number 4.
You said it was.
I did it right at the
10
end
by
of
10.
class, but I want to explain it a little bit better today. Why don't I don't remember going over this at all. Anyways,
You talked
No,
about
you
it, but
only
you
did
didn't really
4.
go over it. You only
only number 4.
Yes.
Yeah.
No, that's what we said.
I kept thinking 1 through 4 when you were saying that. I'm like, I don't think I did that. Okay. So it says this transparency shows pH scale and the pH of some common substances. What is the most acidic substance shown on the transparency? How do you know? And it's lemon juice. And how do you know that? The lowest pH. So what that would mean, look up here, is if this is the OH minus, this is the H plus, your H plus is way higher than your OH minus. Okay? So remember, all of these substances on this chart, all solutions have OH and OH minus and H plus, all of them. Now the solid baking soda actually doesn't have any H plus yet, but if you put baking soda in water, then you'll have H pluses from the water. So all solutions have both. It's all about that ratio. Okay, it's all about that ratio. 2. What is the most basic substance? How do you know? I think it's drain cleaner. Yeah, drain cleaner has the highest pH. What does that mean? It has the most or the biggest difference in OH minus and H plus. There's more OH minus than H plus. So that's how you know number 2. Number 3, which is more basic? Household ammonia or milk? What do you guys think?
I said.
I heard ammonia.
Yeah.
Yeah, ammonia. What's the pH of ammonia about? It's between 10 and 11, right? Let's say 10, just for argument's sake. So milk is a pH. So Brad, I think I graded that one.
So,
No, I'm looking at the wrong. I'm looking at the wrong. Why does he have this?
oh, because you said he wasn't here, so he didn't have a thing. So you gave it to him.
Well, he corrected it.
Oh, to give him like the right answers or
Oh,
whatever?
yeah.
Oh, no, thanks for being helpful.
Thank you.
That's very helpful, but I already graded it.
Oh, okay.
Sorry, Caps.
It's alright, not all over the place.
So,
Well, look at that one. Okay.
yeah, just look at it right now. See if you make sense of some of those. That's more important than what I'm talking about right at this moment. Yeah, ammonia or milk. Ammonia 10, milk 6. So ammonia is obviously more basic. All right.
For the most acidic, you want the lowest number. For the most more basic, you want the higher number.
Yeah. So on the scale here, really, really acidic is here, and then all the way up here is really basic. Yep. And then 7 is water. It's neutral. It's in the middle. How many times more acidic is milk than baking soda? So milk is 6, right? And baking soda is 10. So yesterday at the end of class, I explained it, but I want to talk more today about it. So if you have a pH 6, 7, 8, 9, 10. So here's the milk, and here's the ammonia. Right? Does it say milk and ammonia, or am I making that up?
Baking soda.
Oh, baking soda. Okay. So what's baking soda?
8.
8. All right. So here's your baking soda. Okay. Now, 1, 2 places on the pH scale. So what's that a factor of?
10.
It's a factor of 10 for each change on the pH scale. So this is a factor of 10. That's a factor of 10. So if you're going up from 6 to 7 to 8, so it's 10 times 10. What's 10 times 10? 100. So the answer to this question is 100 times. 100 times. So milk is 100 times more acidic than baking soda.
I thought it was
10 times 10 is 100.
no, because I thought it was 10 times 10 for one interval and then 10 times 10 for the other.
It's times 10 for each interval. That makes sense?
Yeah.
You sure? So a change of 1 on the pH scale is a factor of 10.
I think you definitely said 1,000 yesterday.
Yeah.
Gosh.
That was for 3. I mean, I could have made a mistake, but I doubt it because, I don't know. Well, no, I do make mistakes, but maybe I made a mistake. But the point is, each unit is a factor of 10, so 6 to 7 would be 10 times more basic. 7 to 8 is another 10 times. So 6 to 8 is 100 times more basic, or if you go the other way, it's 100 times more acidic. So whatever you guys were thinking before right now, let's just try and get it straight. So each change is a factor of 10. So if I have something with a pH of 2 and something with a pH of 5, the way I do that is I say 2, 3, 4, 5. So this is 1, 2, 3. So that's 3 tens. What's 10 times 10 times 10? 1,000. So a pH of 5 is 1,000 times more basic than a pH of 2. Or you could say it the other way. A pH of 2 is 1,000 times more acidic than a pH of 5. Really, it's more of a memorization thing. The explanation is because of the H plus concentration. So I'll explain that again later, but I just wanted to go over this question here. Some of those make more sense?
Yeah.
All right. What would happen to pH of milk if lemon juice were added to it? Dan says decrease.
That would taste disgusting.
Right? If you add lemon juice with a pH of 1 and you pour it into milk with a pH of 6, do you think it'll bring that 6 down?
Yeah.
Yeah. So the pH will go down. Good job. What would happen to the pH of lemon juice if household ammonia were added to it? It would go up. If you're adding ammonia, which is 10, to a pH of 1, that 1 is going to increase. Right? So when you add the ammonia and the pH, or the lemon juice, they're both actually going to, the 10's going to drop and the 1's going to increase, but you're looking at it from the lemon juice perspective, so it would increase. What would happen to the pH of distilled water if 1 drop of ammonia were added to it? It would increase slightly. Yeah, it would go up a little tiny bit. It would go up a little bit. On a pH scale, what is the range? That's a weird question. It's just 0 through 14. That's what they were looking for, 0 through 14. And then what is the pH of a neutral solution? 7. Yes, 7. Good job. Good job. All right. Now what you're going to do, take out table M, take out your notes. I'm going to show you a bunch of little demonstrations here. What's up?
So you said,
Hold on, Justin. Go ahead.
so there was such thing as a pH.
Yes.
What has it as a pH?
A strong, really strong acid. And ask me that again after this. What's up?
Do you have anything that takes permanent marker off? Wait, what would
What did you do?
How much of it?
You have to take an expo marker right over it, then just erase it.
Yeah,
That works.
sometimes works.
I use a marker.
Try it. I don't think that'll work, but
No, man.
Justin, what did you
I have
draw?
board cleaner. That might work.
It's not big.
Yeah.
What'd you write? I was playing hand. Oh, nice. I did.
Yeah, you really did that?
Yeah,
All
I
right.
really did it.
Okay. I guess things happen. Good luck. All right.
All on video.
I'll just do that. I don't really want to get you guys again. All right. So you need table M and your notes. You're gonna write down observations that you see. All right? That's what you are going to do. Then we're going to talk about it. All right, here we go. So, hold on, I got to do this in secret. So Dan and Brad don't watch. Plus,
Actually, I can see right now.
I don't know if you're actually,
Am I right though? What I said in lab? What you're gonna do?
I don't know what you said.
Don't tell me or I will freeze.
Because you said table M, so I'm pretty sure I'm right.
He's planning your murder.
Well, we're already making deadly orange.
I will never take orange juice from you because
And deadly for
Well, I don't even know how.
We'll figure it out. We'll figure it out. Don't tell him you don't know how. You have to keep it secret.
You don't know how to make deadly orange juice. You know how to make nuclear orange juice.
Nuclear orange juice?
Oh, that's even scary.
Not a good idea.
Well, I feel like that
Didn't
was
somebody kill somebody using nuclear coffee?
for sure.
What the hell is nuclear coffee?
Like they
Language,
put
young
radiation
lady.
in someone's coffee and it took them like 20 years to kill them.
Language.
Yeah, this is all being
Well, it wasn't
recorded.
a prank, it was like, you know,
Yeah.
somebody
I don't have
killed somebody.
sensors.
Corey, every time someone scores, just yell.
So,
Oh my gosh, that person died after nuclear
Okay.
coffee.
Alright, here we go. So, I have 3 indicators. I have bromthymol blue, phenolphthalein, and phenolphthalein, and methyl orange. I have litmus paper. I have blue litmus paper. And, Caitlin, do you need to shift or something so you can see? Alright, just want to make sure you follow what's going on here. And we have red litmus paper, and we have pH paper. I'm going to take these out. Just kind of showing you what's going on here. So this is what pH paper looks like. It's just like orangish, I guess. So there's pH paper.
What?
This is red litmus paper, but it's more like pink. This is what red litmus paper looks like.
Oh. Sweet four.
And blue litmus paper. So I'm going to show you what the litmus paper looks like when I put acid and base on them. So, did it work?
Brad said it works. I didn't have to use it.
That's really bizarre.
It isn't bad. You put a regular marker over it and it.
Apparently, if you put a Expo marker over it and then erase it, it goes away.
Yeah.
It must mix somehow.
Nail polish does
We gotta
that.
do
It must,
that.
yeah, it must
Nail
combine.
polish does that.
What's that? What?
If you have like a colored nail polish on and you put another nail polish on and wipe it off, it all comes off.
Yeah, that's what it must mix, like chemically bind with each other.
Unbind.
This is
Yeah, like much like.
Blue litmus paper.
We should test that theory.
So this is blue litmus paper. Here we go. Here's what we're gonna do. I'm gonna
We're
take some acid and some base, and I'm going to put it on the litmus paper. You're gonna write down what happens. Okay, here we go. Now,
Getting Dan in there.
I don't want to.
Wow.
I was supposed
Well,
to.
here, I can just move.
No, no, no.
but if you don't care, then.
No, no, you don't care.
Shrink down.
All right, here we go. So
Pretty sure he's okay with his face being in a movie.
A movie?
you can sit up there.
Oh, movies.
All right. So
At AC games. Oh. For a second, I thought he might have been stuck like that for life.
Maybe they would have got me afterwards.
Or at least have to get the jaws in life.
But we don't know what's in the test tubes.
no, you don't. Okay. Here is what happens when you put acid on pH paper. Write down your observations. This is acid on pH paper. I'll show the video. Acid on pH paper. Now, here's the cool thing. This has a color code on the side. So all you have to do is match it up.
Is that red or pink?
First of all, what do you think?
Like a red.
Yeah, what pH?
1.
1. This is the pH of 1. I'm not going to go around and show everybody, but pH of 1 because this red pink color matches up with the pH of 1 color. So that's how you use pH paper. Red litmus paper with acid. Red litmus paper with acid, it just looks wet. The color doesn't change. It's still red. Bless you. So this is what red litmus paper looks like with acid.
So there's no pH.
Say that again.
Like,
No, you. Fine.
the last one had pH.
Yeah, this one doesn't tell you the pH. It just tells you if it's an acid or a base. That's what I'm trying to teach you. That litmus paper doesn't tell you the pH. pH paper tells you pH by the color. Litmus paper just tells you if it's an acid or a base. So red litmus paper with acid on it stays red. Now this is harder to see. It's just these litmus papers aren't working so well. But the top of this blue litmus paper should be red. Should be red. Should be light pink. It's a little bit light pink. It's just not reacting very well. I think maybe because my acid is too weak. I can try another one if I have time. One of those other acids might be a little stronger. But you can see the difference, hopefully, between the top part and the bottom part. But the bottom is blue and the top is light pink. So what's supposed to happen, I kind of have to tell you, what's supposed to happen is the the blue litmus paper, the top part will turn red, turn pink in the presence of acid. So the point is, anything you see that's red is going to be acid. So think acid, think red. Now, I'll put a base on all the same ones. Well, same type, but different strip. Yeah.
If it's acid, why wouldn't it just eat at the paper?
It's not that strong.
Oh, okay.
Plus, not all acids eat through paper.
What acid would eat the paper?
Sulfuric acid.
What is like the strongest acid?
They're super acids.
Really?
What do they do?
Sulfuric acid?
What do they do?
Yeah.
Like, what are they using?
They're super corrosive.
What are they used for? Yeah.
That's a good question.
Maybe they're like, hey, now that you have it.
I actually looked it up and I can't remember it now off the top of my head. This is what happens with pH paper and a base. What color is that?
Dark cobalt.
Yeah, dark cobalt blue, right? There you go, dark cobalt blue. So pH paper turns dark blue. What do you think, Destiny? What color? Or what pH?
10.
About a 10. So 10 is that dark blue. So we know that this base right here is a pH of about 10.
What do they keep like super acids in?
That's a good question.
Glass? Paper. They keep it in paper.
Yeah, probably special glass. Or maybe they have it levitate between two really strong magnets so it doesn't touch anything.
Wait,
Are you serious?
That's genius.
Alright.
magnetite?
You can do that with certain substances. You can do that. So, this is red litmus paper in the presence of a base. So again, you're writing these observations down. I want you to write these down. This is red litmus paper in the presence of a base. And it turned what? Blue, right? Yes.
That was the one that just looked wet before.
Yeah, see, this is red litmus paper with acid. Look here. Red litmus paper with acid. Acid. Red litmus paper with base. Base.
So basically acids are red and bases are blue.
Bases are blue, acids red. Very good. Roses are red, violets are blue. Wait, what? What are we talking about? So, blue litmus paper stays blue. It stays blue, it just looks bluer, actually. So that's blue litmus paper with a base. Yes, sir.
So what metals would be in a super acid?
What metals would be?
For it to be able to be magnet with, that.
You can, I just kind of like made that up. I know that certain things can be suspended by magnets. I don't
Yeah.
think superacids could be.
Alright.
But I know that they probably are very reactive, so it's probably hard to store them.
What if they just have
So I
like,
wasn't serious. I don't know how they do that.
what if they have like a massive fan, and so the amount of air holds it up?
Like when people do fake
Yeah,
skydiving?
or like, yeah.
Yeah, so it like
Alright.
finally floats over to the
Now,
side.
so you got all those observations. Now, I'm going to add bromthymol blue to test tube number 1. Here's test tube number 1. Write this down. Bromthymol blue, test tube number 1. Here we go. Bromthymol blue. It's on table M. Bromthymol blue. Bless you. If I mix it up a little bit, you guys see that color? Yellow, right? So just write your observations down. Write your observations down. Test tube 1, bromthymol blue turns it yellow. Test tube 2, phenolphthalein. Now this morning it stayed cloudy, and that really irked me. It was very irksome. Phenolphthalein, test tube 2. It's still cloudy. I don't know what's going on with this thing. So let me see if I can shake it up a little bit here.
I'm guessing it's supposed to be clear.
Yeah, it's staying cloudy for unknown reasons. Usually when I add phenolphthalein to a solution, it's in a beaker or a flask. And if I swirl it, it might be cloudy, but then it goes away. So the point is, on table M, there's 2 colors for phenolphthalein. What are they? Colorless and pink. This is not pink, obviously. So it's supposed to be colorless. I really don't know why it's cloudy. I think, again, because phenolphthalein is kind of old. There might be contaminants in the test tube. Not sure. So that's phenolphthalein. Test tube 2. So colorless, yeah. It's supposed to be colorless. So I apologize for that. And test tube 3 is going to be methyl orange. Test tube 3 is methyl orange. So there's methyl orange in test tube 3. No, I'm glad it's not orange, because there's only 2 colors your reference table gives you. Yellow and red. So, no, it's okay. I'm not making fun of you. I'm just saying, because it could be orange. We're going to talk about that. It could be. So this is methyl orange, and obviously it turned like a reddish pink type color. Okay. All right, next. We're going to do it all again, except test tube 4, 5, and 6. So here's test tube 4. BTB, bromthymol blue. Bromthymol blue.
The same thing that was in the first.
Yep, same thing in test tube 1, except this is test tube 4, and notice it's not yellow anymore.
Purple.
Purple blue, right. Purple blue. It's like a dark, really dark blue. A royal blue.
Wait.
Navy blue?
Indigo.
The same thing that was in
Yeah,
the
it's
first one.
indigo.
Indigo, sure. So, I'm going to say blue. Bromthymol blue in test tube 4, it's blue.
Indigo.
Right, but that's not an option. So.
What is the difference between that one and the yellow one?
One's yellow, one's blue. That's the difference.
Or why?
That's what we're going to learn. So, now, phenolphthalein in test tube 5. Phenolphthalein in test tube 5.
Whoa.
AKA pink. So write your observation.
You guys are all coming up with such intense colors.
Yes.
See, these are your colors to make you feel
Wait, so I have
happy.
a question.
Dark cobalt.
Right? Doesn't this? He can't look at this and not feel a little happy. 1, it's chemistry. 2, it's pink.
It matches your shirt. Just pink just makes
yeah.
everything better.
All right. Now,
It does.
oh, I don't know why I put the top on that.
And that's coming from
Number 6. Number 6. Methyl orange in number 6.
It's orange.
Wow.
Nope.
This is yellow.
Aw.
Dandelion.
Oh, how dare it be yellow? They're too yellow.
Oh, you're peeing.
All right. Methyl orange.
I don't know. What I think was at
So,
it's all dehydrated orange people and all the
Yethel? I said yethel. Yethel orange. Methyl orange, yellow in test tube 6. If your pee looks like this, you need to drink a lot of water, because that's not good.
Wait, why is that pink anymore?
It's all dehydrated.
It's getting light pink now,
It's faded.
because it's reacting. It's getting light pink. We're going to explain that.
Base.
Okay, but it's still pink. It's just light pink. Good job, Megan. Good observation. All right, now let's talk about which one's the acids, which ones are bases. So, based on what you already learned about table M, test tube 1, bromthymol blue is yellow. What's that mean? It's an acid, but let's be more specific. What's the highest pH this could have?
6.
7.6.
Bromthymol blue is yellow. So the range on table M is what? 6 to 7.6? 6 to 7.6? Okay, 6 would be the highest pH level for this, because it starts to turn to blue in between 6 and 7.6. So we know this is at most a 6. It's probably less than a 6. You guys following me?
Yeah.
Yes? Are you following me? Do you have reference table M out? Yeah, and your notes? What are you doing? We got tons of time.
No, we don't.
Yes, we do. We have at least 4 minutes. That's tons of time.
Actually,
Stay with
time
me.
is weightless.
Now, this is phenolphthalein in test tube 2. It's colorless.
I said that.
Acid, however, it could be up to a pH of, look at table M. 8. 8 is the highest pH where it's colorless. Then it starts to turn.
Could be a base.
So it could be a base, but a weak base. It could be barely above 7. This is what I want you to understand. The colors on the left, in general, are for acid. The color on the right, in general, for base. But you got to look at the pH and look at the scale. This could have a pH of 7.5. It's colorless, and it could be a base, but it's barely a base. Okay? So just keep that in mind. Methyl orange. Test tube 3, it's red. What's that mean? Acid, but it has to be a pretty low pH, right? Below what number? 3.1. 3.1 or lower is the pH in here. Okay, it's an acid, but 3.1 or lower. Now, test tube 4. Brown thymol blue is blue. Base. What's the pH here? 7.6 or higher, right? 7.6 or higher. Phenolphthalein, it's light pink, which means it's probably somewhere between the 8 and the 10, to be honest with you. Or 8 and a 9. 8 and a 9. Somewhere between 8 and 9, but we're going to say, according to the charts, about a 9, right? Or a little bit higher maybe, but that's because it is slightly pink. So pink means base, but above 9. And then the last one here was methyl orange, test tube 6. It's a base. How do we know that? Well, we actually don't know. It could be an acid, right?
Yeah.
But its pH is going to be
Above.
above 4.4 for methyl orange because it's yellow. So that pH range and the color change coincide. It's very important to be able to read that chart. So again, the point of showing you this is seeing them, relating them to table M, and understanding how to read it. The other thing is pH paper, litmus paper. If litmus paper turns blue, what's the pH? According to table M. If it turns blue.
Oh wait, 8.3.
8.3, what about the red litmus paper turning red or staying red?
4.5.
4.5. Okay? So just keep in mind that's how we read it. Yes?
Would the regions ever be like, okay, here's...
No.
Okay, so
They're not going to give you one in the middle and then ask for color.
You already said it. Second one. If you wanted to change the color of the paper
Ben.
would you just put it in a different...
No. Good question. Paper won't change color, but indicators will. Watch this.
Wait. How did you get that color in the first place?
Wait. This is an acid in here, so I put brown thymol blue. It turns yellow.
So if you were to put more
Watch. Magic.
I'm so excited.
what is that you're putting in?
Safety first.
Yeah. Look what happens. When you add a base to it, it turns blue because that's brown thymol blue. So once the pH gets to a high enough level to turn blue, it turns blue. That's how indicators work.
Wait, so what was in there before?
Acid was in before, and
So
I
what kind of acid?
hydrochloric acid. Then I added sodium hydroxide.
So wait, if you were to put like a red goes to blue.